Uh, in this lecture, we will be learning about the insertion sort. So, sorting means you are arranging the data that is present in some order. So, if you want to save the numeric data, you will store the data in ascending order or descending order. If you have data in alphabetical order, so then that can be also in uh, ascending or descending order based on the names or numbers. So here. Uh, So sorting algorithm, if you just see here the definition, if you want to take a list of object and you want to that can be stored in a linear order, like if there are n elements, so that can be n a naught to a n minus 1, and numbers after ordering, it can be, it will go up to 0 to n minus 1 index, but the element will be different in order. It should be in that manner that the first element should be less than the second element, second should be less than the third, like n element. So like this, you can say your element is in sorted order if you are keeping the element in this way. Now if you want to know what is sorting, so suppose you have, for example, if you are considering this array, so this array contains 1 2 3 4 5 6 7 8 9 10 11 12 13. Out of 13 element, 8 elements are already in sorted way. Now if you want to insert this ninth element in this sorted array, so where it should be placed, right? So that the resulting array should be in the sorted way again. So the one way that you can compare this 14 with each and every element of the array, and then wherever it is the element is less than this element, so you will keep the element right to that particular element. So like see here, this 14 is compared to 40. So 40 is more than 14, so it is shifted to this way. Then 14 is compared to 33, then 33 was more than 14, so it was shifted here. Then 14 and 26, 26 was shifted here. Then 14 and 21, 21 was more than 14, so 21 was shifted here. Then 14 and 19, now you can see here 19 is shifted here and 14 here. Now 14 and 12 are compared. Now 14 is greater than 12, so you will place 14 here. No more shifting is required, no more comparison is required. But comparing each and every time with each and every element is time consuming process, or it is increasing the complexity. So we want to use some kind of sorting algorithm. So I want to discuss the first sorting algorithm, that is the insertion sort. So in the case of insertion sort, what happens, just think about that. So you have one sorted array and you have some element in unsorted array. You want to insert element of the unsorted array to the sorted array. So when you are inserting the element, at the time of the insertion, you are keeping sorting in mind. You cannot insert anywhere. Wherever you are inserting your element, that will keep your remaining element of the sorted array in the sorted manner. So that thing you need to keep in mind if you want to use the concept of insertion sort. So uh, as I told you, you will divide the complete list or array into two parts: sorted and unsorted, right? So treat the first element as a part of the sorted list, because if in a list there is only one element, that need not to be sorting, right? Because one element will always be in the sorted case. Now what about remaining k minus 1 element? And consider k minus 1 element as a unsorted element that you need to add with the sorted list. So so that you can make the list of the size k up to k. So if I want to give one example here, suppose you have an array that element has 3, 9, 5, 6, 2 and 8. So as I told you, first element will be part of the sorted array and remaining 5 element, right? Because there are 6 elements, the remaining 5 element will be the part of unsorted array. So from the unsorted array, you will pick the first element, right? And you will compare this element with, you will insert this element in this sorted array such that the sorted array should be in the sorted way, right? So I want to insert 9, right? So what I'm just doing, the element that I want to insert is kept in a temporary variable, right? So I'll store this 9 here, and here this will behave something like this: 3, and this place will be vacant because the value is shifted here. Now 5, 6, 2, 8 will remain same. So till here, this one is sorted, this one is unsorted. I am picking the first element from the unsorted list and trying to insert in the sorted order. Now this 9 will be compared with each and every element of the sorted list in the backward direction. So 9 will be compared with 3, right? So 9 is greater than 3, so don't do anything, right? And there is only one element, so no shifting will be there, no swapping will be there. 9 will be here only in this vacant space. Now your sorted array list will be till here, and unsorted is this one. Now coming to this 5, right? Now in the temp, I'll store 5 and this place will become vacant. Now 9 will be compared with 5. So 9 is greater than 5. So 9 will be shifted here and this place will become vacant. You cannot keep 5 here because you don't know whether 5 is less than or greater than the remaining element. Then you will compare this temp 5 with the other element of this particular sorted list. So 5 is compared with 3, so don't do anything. 3 will be here, and here in this vacant place you will keep 5. And now 6, 2, 8. So now your sorted array list will be increasing. Now these 3 elements will be inserted in this particular sorted list in the same way. So if you see this example, another example, so you can see here this one was the list and I wanted to insert 14 in this particular. So here I have performed this particular insertion operation till here. Now this one is my unsorted list, right? Now I'm picking the first element from the unsorted list and I want to insert in this particular sorted list. The 14 is picked. 14 is assigned in temporary variable temp. Now this 14 is compared to 40. So 40 is more than 14. The 40 is shifted to this place and this place remain vacant. You will not keep 14 here. 14 is again compared to 33. That is the next element in the descending order in the sorted array. The 33 is greater than 33. Again 33 is shifted here. This place remain vacant. Now 26 is compared and 26 is shifted because 26 is greater than 14. Now 20, same with 20, same with 19. Now coming to the 14 will be compared to the 12. Now you can see here 12 is less than 14, so no need of swapping. So temp will be shifted here in this particular vacant place now, and you can see this array is sorted array. So the sorted array list is shifted by 1. Now unsorted array element is only 4 here. And if you see here in the case of algorithm, in the part of algorithm, so I just want to show through one example. The same example: 3, 9, 5, 6, 2 and 8. Here number of element n equal to 6, and sorted array this one, and unsorted array contain 5 element, that is n minus 1, that is 5. Now loop will run up to 1 to I less than n. So n is 6, so it will go up to 1 to 5. Now in the key or temporary element, you can keep array I. So array I is array 1. That is 3 is kept here. Now I want to check 3. So now j equal to I minus 1. So value of j will be 0. Right now I'm checking for 9 here right now. So j is 0. Now this while loop will be used for inserting element in this particular sorted array list, right? So this 9, so what will happen? J greater than equal to 0. So right now value of j is 0. This condition is true, and array of j is 3. So whether 3 is greater than key. In key I am just keeping here in key I am just keeping 3 here, and array of 0 is also 3. So this condition is false. So it will not go inside this while loop. And what will happen? Array j plus 1 equal to key. So j plus 1 is, it will be 1. It will be 1. And here I'll keep the key, that is the 9 here. Okay, so here array I is not 3. That will be 9 here, right? So array j is 3. 3 is greater than key. No, right? So you will not perform this shifting operation. You will make array j plus 1 as a key. So j plus 1 is 9. So here 9 will be present. Now coming to the 5, right? So in this case, the value of I will be incremented by 1. So now the value of I is 2, right? So array 2 is 5. Now value of j equal to I minus 1, that is 1. So j is greater than equal to 0, that is true. Array of j, so array of j, that is array of 1. Array of 1 is 9. Is 9 greater than key? So in key 5 is present right now because I just want to shift 5. So in key 5 is present. So 9 is greater than 5. That means I need to perform this condition and this condition. Both are true. Now I need to do the swapping operation here. 5 and 9. So what will happen? It will not be swapped, but what will happen? This particular 5 and 9. So 9 will be coming here, but at this particular position, nothing is placed. So it is vacant, and j will be decremented by 1. So now jth position will be at 0th position. Now what will happen? Array of 0 is 3, is compared with this particular key, that is the temporary variable 5. So this condition is false this time. So what will happen? Array j plus 1, that is array 1. In array 1, I'll keep key, that is the 5 and 3. So like this particular loop will be running until and unless complete array is sorted manner. So if you consider the time complexity here, it is of big O of n square in both case, worst case and base case. So it is running. So there are two loops here, one loop here and one loop here. Both are running up to n time. So in this case, n cross n. So loop within the loop, that will be going to the multiplication n and approximately n. So n cross n is approximately n square times. So this one will run approximately big O of n square times.